In this video, we'll use circle geometry to determine the values of x, y, and z in the following diagram. So let us inspect our diagram. First, I see that we have O as the center of the circle, and nowhere on the diagram do we have any parallel lines or equal lines indicated. We can see that x is an angle within the triangle DOC, and if I just inspect that triangle, I notice that we have 56 degrees. Also, what we know about this triangle is that OD is equal to OC, because the line from O to D is the radius, and the line from O to C is also the radius. And if these two lines are equal, then angle C2 would also be equal to x. Then we could use the angles within a triangle to solve x. So let us quickly write that down. To find x, we can say OD is equal to OC, because these are radii. That means that angle C2 is equal to angle x, and the reason is angles opposite equal sides. We do not say isosceles triangle, we say that these two angles are equal because they are opposite equal sides. Then we can say that x plus 56 degrees is equal to 180 degrees, and our reason is sum of angles in a triangle. And the triangle that we are focusing on is the yellow triangle that we have indicated. That means that x is equals to 180 minus 56 divided by 2. Therefore, x is equal to 62 degrees. Now let's go back to our sketch to find the values of y and z. So let us focus on y. We notice that y is in the triangle ADB. And we already have the angle size of B. So the angle size of A would be 90 degrees, because DOB is the diameter of the circle. And we can use angle in a semicircle to find the angle size of A, which is 90 degrees. So if A is 90, then we can use angles within a triangle to solve the value of y. So let us quickly write that down. We can say that A is equal to 90 degrees, and the reason is angle in a semicircle. Then we can say y is equals to 180 degrees minus 90 minus 26 degrees, and this is the sum of angles in a triangle. And the triangle that we are focusing on is the pink triangle, or the triangle ABD, which we indicated on the sketch. Therefore, y would be equal to 64 degrees. And our last question is to find the angle size of z. Now there are two ways to go about this. You can either find z using angles within a triangle, and you can prove that OB is equals to OC radii, and then z is equals to C1, and you can use angles on a straight line to find O2. Then you'll have enough information to find the angle size of z. But the shorter way is to recognize that the arms of the angle z is connected to the angle at the center. And what we know is that the angle of the center of the circle is twice the size of the angle at the circumference. So therefore, z is equals to half of 56 degrees, which is 28 degrees. And our reason is angle at center is equals to 2 times the angle at the circumference.